Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, moderator. Good afternoon, all participants, presenters, and audience of International Conference on Multidisciplinary Engineering and Technology, ICOMET 2022. I'm Amir Hafizum bin Abdul Rashid from University Technical Malaysia Melaka. I'm glad to be here today to share with you an article with the title of Dual Band Coplanar Waveguide Pentagonal Sierpinski Gasket Fractal Patch Antenna for Worldwide Interoperability Microwave Access and Wireless Local Area Network Applications. Introduction. Basically, a single frequency antenna only operates at a single application. Nowadays, the smart antennas must be able to operate with several frequency bands using single devices in order to serve a variety of wireless communications such as the radio frequency identification, RFID, worldwide interoperability for microwave access, WiMAX, wireless local area network, WLAN, global positioning system, GPS, and a global system for mobile communication, GSM, AWAN 2021. At the moment, current communication system require the use of antenna with a wide bandwidth, enhanced efficiency, and robustness during transmission and reception, which is why implementing them using conventional design has rendered them obsolete in some circumstances. Overview of antenna. This is a basic design of antenna. An antenna is a device that converts energy into electrical signal. A transmitting antenna radiates electrical and electronic power and energy from an amplifier in a confined region, such as a wire or a waveguide, into free space as electromagnetic power, or we call EM. Radio wave travel through the air. Electricity flowing into transmitter antenna makes electronic vibrate, producing radio wave. Radio wave makes electron vibrate in receiver antenna to produce electric current. Antenna concept as energy transducer, dispersing electromagnetic power into free space or capturing it from space. Overview of patch antenna. The most basic form of the fundamental microstrip patch antenna design are the foundation of all antenna designs. The metallic patch can be made in a variety of shape and size, including rectangular and circular patch. A dielectric substrate separates an electrically large ground plane radiating patch from the basic microstrip antenna, feeding line, and matching network that may be produced at the same time as the antenna structure. Ground plane refers to the lower conductor, while patch refers to the upper conductor. Overview of fractal geometry. Fractal geometry was developed and pioneered by Mandelbrot, 1977. It derived from the Latin word fractus, which meaning fractured or uneven fragment, Mandelbrot, 1972. Fractal are symmetries which are invariants under dilation and contraction. There are 4 types of fractal geometry. The first one is Koch snowflake, Sierpinski gasket, Minkowski, and Hilbert curve. The figure shows there is a step-by-step for iteration stage of fractal structure. Advantages and disadvantages of fractal geometry structure. Advantages is 4. The first one is miniaturization size, better matching of input impedance. One antenna is sufficient to take care of multiple bands. And the last one is reduction of mutual coupling in array antennas. Disadvantages: complexity involved in the design and manufacturing process, numerical limitation, and the last one is the benefit will diminish after several numbers of iteration stage. Overview of Sierpinski gasket. The Sierpinski gasket also known as the Sierpinski triangle, is the intersection of all the sets in this sequence. That is, the set of points that remain after this construction. A noteworthy fractal geometry is the Sierpinski gasket, discovered in Sierpinski 1916. Sierpinski gasket inspired fractal multiband antenna with 5 distinct heights and a factor of 2 between scale were pioneered by Puente in 1996. Because of the rotational symmetry of an equilateral triangle, there is second iterated function system that has the Sierpinski gasket as its attractor. In addition to, to scaling by a factor of rho equal to half, rotate 2 of triangle by 120 degree and negative 120 degree, then translate. Sierpinski gasket iteration stage. Start with a solid field equilateral triangle of initiator step 0. Divide this into 4 smaller equilateral triangles using the midpoint of the 3 sides of the original triangle as the new vertices. Remove the interior of the middle triangle, that is, do not remove the boundary, to get first iteration step 1. Now repeat this procedure on each of the 3 remaining solid equilateral triangles to obtain second iteration, step 2. Okay, now we go to the methodology. The initial stage of designing of microstrip antenna began with the antenna basic construction, antenna with triangular, square, and pentagonal shape. The next design is antenna A and antenna B with first iteration and second iteration of the pentagonal slot and pentagonal element structure. This antenna was built on a FR4 substrate with a thickness of 1.6 mm and dielectric constant of 4.3 with the copper thickness of 0.035 mm. The antenna is consisted of 2 stages of development, consists of antenna A and antenna B. For antenna A, the initial stage of designing of microstrip antenna began with the antenna basic construction of pentagonal shaped patch. The coplanar waveguide CPW technique also applied at this antenna. For antenna B, the enhancement process had been done with the implemented the pentagonal slot at the patch. The result for return loss for antenna A and antenna B. For antenna A, it shows that the antenna is operated at 2 different locations of the frequency at 3.52 GHz and 5.97 GHz with return loss of negative 20.71 dB and negative 25.17 dB respectively. The improvement of the antenna B by introduce a pentagonal slot of iteration 1 is effect to shift the antenna performance. In this case, the antenna B had been operating at 2 different location points at 3.32 GHz and 5.77 GHz with negative 21.61 dB and negative 49.98 dB respectively. Result for return loss, simulation versus measurement. The measurement had smaller differential of shifting point of the resonant frequency with compared with the simulation result. It operates at 3.55 GHz and 5.72 GHz as negative 51.48 dB and negative 37.94 dB respectively. At targeted frequency of the antenna at the 3.5 GHz and 5.8 GHz is shown as negative 31.7 dB and negative 22 dB, and this value is acceptable for the operate application of worldwide interoperability for microwave access, WiMAX, and wireless LAN. Third result is radiation pattern. The radiation pattern for antenna B is shown at pi equal to 0 and pi equal to 90 degree. At 3.5 GHz resonant frequency, it shows the same size for the main and also the back lobe of pi equal to 0. At pi equal to 90 degree, it shows the same shape with the different parts of right and left. For 5.8 GHz, it has the same condition for pi equal to 0 with the equal same size of the forward and back lobes. For the pi equal to 19, the condition is different with the lobes is focused on the right side. Okay, for conclusion, in this work, the initiator of antenna A and the second iteration of antenna B is done. From the investigations, it is observed that the change of the initiator shape to the first iteration step of the pentagonal fractal had been effect to the location of the resonant frequency and also effect to improve the performance of the proposed antenna. Thank you.